For lesson 6, we'll be discussing another property called the distributive property. To start, let's look at an expression that's in the form of the distributive property, but let's use our order of operations to solve instead. All right, so 6, and then parentheses, 3 plus 9. Remember, when you don't see a sign in there, when you don't see an operation, it's multiplication. All right, so order of operations is going to tell us we should do that addition inside the parentheses first. So 6, there's an invisible times sign there. 3 plus 9 is 12. Well, now we can do 6 times 12, which is 72. We get our answer. We're not going to do the next two examples. Now, that is a method we can use to solve when our expression has all numbers. But look right below that. How is 7 times x plus 2 different? Well, it would tell us that this is multiplying, and our next step would be to go ahead and do those parentheses. But what's x plus 2? If we don't know what x is, there's no way to say what x plus 2 is going to be and then do 7 times it. It's still just x plus 2. So we have to actually leave it in the parentheses. We can't do that addition. So this brings us to the distributive property that we're going to talk about next. The distributive property allows us to multiply each term inside the parentheses by the number outside the parentheses. So this number out front times each thing inside, instead of adding first and then multiplying like we would do with PEMDAS. Algebraically, meaning using math, we would say A times, there's a little invisible multiplication in there, the group B plus C is going to look like this. We're going to take the A times, and we're going to share it with the B and then with the C. And if there were more things inside the parentheses separated by plus or minus signs, we would keep going. So when we share it with multiplication, it looks like this. A shared with B, A times B, plus A times shared with the C, A times C. Okay? So let's call our keyword for the distributive property share, or sharing, because we're sharing with multiplication the thing out front, the coefficient out front. All right, try it now with subtraction. Same thing. We're going to share the A times with the group B minus C. So with everything inside of there, with each term inside of there. So it's going to be A times B. And now it's a minus sign. And then share the A times with the C. A times C. And that is how we get rid of the parentheses when there are variables, letters, inside the group. And just a quick note here, for 7th grade and beyond, you're going to start to see negative numbers involved in the distributive property. When that happens, just make sure that you're paying attention to the signs when there are negatives and positives involved. We're not going to really touch on that much this year, but you might see it, and you definitely will see it in 7th grade and beyond. In our next example, let's write our own expression using the distributive property, meaning we want a number multiplying a group of terms being added or subtracted. So here's the example. Each of the 4 members of the Robinson family ordered a drink, 2 slices of pizza, and an ice cream cone. And you can see in parentheses that they're giving us our variables. So I'm going to circle those, and I also saw that there are 4 people. So those are my numbers. And I'm just going to underline some key words. So we had drink, that's what the letter D stands for, 2 slices of pizza, so 2 with the letter P, and an ice cream cone, C. So we have a little visual here, 4 outside of the parentheses, and then inside there's a drink, 2 slices of pizza, and an ice cream cone. So translating that picture to math, it's 4 parentheses, and instead of the soda, the letter D, plus, and now there's 2 of these pizzas. So I'm going to say 2P, or 2 times P if you want to write the dot, plus C for that ice cream cone. And all of those variables just came from the problem. All right, next part. Distribute and write an expression to represent this family's order. So if we distribute, it's going to write the expression, okay? So remember, this is multiply, and we're going to share the 4 in the multiplication with everything inside, because the parentheses represent one person's order and 4 people got the same thing. So we have to times all of it by 4. So 4 times the drinks, 4D, plus 4 times the 2 slices of pizza would be 4 times 2 times P, plus 4 times the ice cream cone, 4 times C. Now, that is not simplified in the most official way that we would write it. So I'm going to do one more step. It would technically be okay the way that we've written it. So 4 times D would be 4D, plus 4 times 2 times P. Well, 4 times 2 is just 8, and then P, plus 4 times C is 4C. So what might we use this expression for? Well, if D stood for the price of 1 drink, P stood for the price of 1 slice of pizza, and C stood for the price of 1 ice cream cone, we could use this expression to find the total cost of their order. So 4 times the price of a drink, 8 times the price of a slice of pizza, and 4 times the price of an ice cream cone would give us our total once added together. Looking at number 5, we're going to look at the area model. That is a way to visualize the distributive property. So first, let's just talk about area. Remember, area of a rectangle is length times width. So one side's the length, one side's the width. It really doesn't matter which one you call which. So here we have this rectangle that's really made up of 2 pieces. One of them is 5 by 3x, meaning 5 times 3x is its area. The other is 2 by whatever this side is. Remember, if we go across the rectangle, those 2 sides are the same. So this is also 5. So it's going to be 5 times 2. So if we wanted this total area of this whole shape, we would have to add these 2 pieces. So we would say the area is the 5 times the 3x plus 5 times 2. And we could definitely simplify that a little bit, because we could do the 5 times the 3 and the 5 times the 2. So we'd get 15x plus 10 is the area. But you might be wondering, what does this have to do with the distributive property? We could have actually done this more with algebra, meaning more with the expression, than with the picture, by immediately realizing that, let me just erase here, that if we started out by saying this entire side is 3x plus 2, and then this other side is 5, that the area is just 5 times this entire side, 3x plus 2. And since it's grouped up, we have to put it in the parentheses. So if we got that expression, we could get it to come out exactly the same as our previous answer by using the distributive property. So I'm just going to write that off to the side. So 5 times 3x plus 2, distribute. Share in the 5 times with both parts inside. So it's going to be 5 times 3x plus 5 times 2. Same exact thing that we had here. 15x plus 10. So we got the same answer by doing this 2 completely different ways. For these next few examples, we're just going to practice the distributive property to get a feel for the process. So remember that whenever you have the number out front of the parentheses, there's an invisible multiplication there. We're going to share that 2 times with the x inside and the 6 inside. So 2 times x, 2 times 6. Keep your plus sign in the middle. That's the expanded form. Simplest form is when you simplify this. So we can do 2x, we don't have to write the multiply, plus 12, since 2 times 6 is 12. 8 times the group 7 minus g. So 8 times 7 minus, this time, 8 times g. So see again, we shared the 8 times. 8 times 7, 56, minus 8 times g, or 8g. Now it's simplified. This next set is going to involve variables that sometimes have a coefficient, meaning a number out front. Doesn't really change anything, just adds in one more multiplication. So number 10, 5 times 3x, and then we're going to do plus 5 times 10, shared that 5 times. Now 5 times 3x is actually 5 times 3, which is 15x, plus 5 times 10, which is 50. Number 13, let's go straight down. 6 times 2x. So share that 6 times. Plus 6 times 5. And again, same deal. We shared the 6 times. And now we got to do 6 times 2x. So 6 times 2 is 12x plus 6 times 5, which is 30. One more down below. 5 times both things inside. So 5 times 2x minus 5 times y. Simplify. So 5 times 2 is 10x minus 5y. Now, at this point, you may be wondering, why is it that we cannot go any farther to simplify this? Here's the thing. If you have 10 and then you have 5, you could do the 10 minus the 5. But it says 10x and 5y. They have different variables attached to them, almost like a different label. So they cannot be combined together and they cannot be subtracted from each other because they don't match. It's like saying 5 oranges minus 2 apples. You can't do that. It doesn't make any sense. So 10 x's minus 5 y's, you can't do anything there. It's the same as up here in number 10. 15 x's can't combine with 50, because it's not 50 x's. So plain old constant numbers can't combine with terms that have variables, and terms that have variables, the variable has to match if you want to combine them. Like 2x plus 3x, the variable matches, and we'll be able to talk soon about what that looks like when you combine that. But if you change this to a y, now you can't combine it. So that is why we are done with all of these examples that you see on this page here.